Tiddy, overhead line maintenance support network rail. Work for the route asset management team in Wales and Cardiff. And Jay Parhar works with me on maintenance support, and we cover from Paddington up to Cardiff, down to Newbury. So quite a bit to cover. So first of all, thanks for inviting us back. It's the third time we've done a show with the PWI. So come in. It's good to be back. We've done a couple of sessions over the years with the IET. So pleased to be back, and it's nice to be valued. So this is a bit different. This is about pantograph monitoring, and we're going to take a look at that and what we've learned. And Jay is going to spend some time looking at the case studies. I'm into quite interesting case studies where we're on a journey with this stuff, and we've learned quite a bit. So that's what we've got. You can see it on the screen. So we've got a system called PanView, which is a set of overhead mounted cameras or line side cameras which look down at the pantograph. And there's two cameras and a series of illuminators, and that will take an image and that will produce a 3D model. From that model, you can then look at the carbon condition and the pantograph condition. On the side of the track, you can see these two items here, devices. They're the train identification system, and that takes an image as the train goes through. But there is an added benefit, which is not just looking at the pantograph. You can actually look at the side of the train, and it is useful for the train operators to look at the side of the train to look for any damage, vandalism, whatever it may be, and useful for that, as well as being train detection. Okay, so I won't go through the agenda in detail, but as you can see, there's some key items there. We'll have a look at why it's important to monitor pantographs, why we do it, where we've got PanView, which is a system produced by Camblin, a little bit about maintenance, and then Jay's going to look at some case studies. Then we move on to a little bit on thermal imaging, which we've used to good effect on the region. And then we'll open it up to some questions and answers. Okay, so that's a view from PanView looking down. And what you can see is a nice, clean pantograph, no damage, no chipping, contact wire. You can see the catenary and the contact wire on the carbon there. And as the early engineers in the room, you know that it's always a balancing act between the correct geometry and the grading of the wire and the condition of the install and the maintenance and the management of pantograph. So everything needs to come together to give us that good current collection interface. So there is this challenge of getting design, we put it into construction, what we end up with is something sometimes a little bit different. So a good interface is important. That's what makes that gives us good current collection. And what PanView does, it allows us to pick up anomalies if those interfaces go out of a good relationship. When it all goes wrong, sometimes that's what you can end up with. That's what happened with us. We managed to lose pantograph, and we've got all sorts of things go wrong over the years. So early detection is important. You see that you catch something before it does go wrong. So that's the same on the overhead line and with the pantograph. PanView gives us a good status on current collection. So if it's pantographs aren't chipped or bumped or the horns aren't bent, or whatever it may be, you can see that on PanView. So pantograph monitoring gives us that sort of holistic, almost real-time view of what the pans are doing. And it has prevented pantograph monitoring, as we've used it on Wales and Western, has prevented several derailments in recent years, and Jay will go through those case studies shortly. So you may remember this system. This system is a system called PanChecks, which was installed. This photograph is courtesy of the PWI, which was installed on at Southall on our route back in the 90s on the back of the 0 to 12 Paddington to Heathrow, the original Mark 3B installation. So this kit sort of went out of commission during the early 2000s, and as we then installed Great Western Electrification and marched all the way to Cardiff, there was no pantograph monitoring system in place, albeit in some kind of fashion. It was in the scope of Great Western Electrification. I think for budget reasons it dropped out, but we were short of any pantograph monitoring capability. But there was a major incident in 2017 where we managed to shut the railway for 2 days between Paddington and Heathrow, because we took some one pantograph was severely damaged and we couldn't find out where that cause was. So we had to put a MUP all at Paddington and send it to Heathrow and back. That took 2 days and nights. And then the route director said, "You can't even find the haystack, never mind the needle." So at that time, we had discussions with Heathrow Limited, and they were keen to say, "Well, let's put a gate, a monitoring gate on the portal at Heathrow, so at least we can establish if there's a problem inside the tunnel or outside the tunnel." So we worked closely with Heathrow, and they procured a system called PanView by Camlin. That's installed at the portal at Heathrow. So that's why we do it. And of course, we had this sort of gulf where we had no pantograph monitoring system on the network. So the way we used to do that was we get notified. We get notified by members of the public if there's a problem with patterns running around, probably, or the TOCs, more often than not, or we put people on bridges. So there was many an hour spent on a bridge in Paddington or somewhere else looking at pantographs with binoculars. And we used to do that for a long hours on end, and monitor which trains were damaged and where they'd been and so on. And looking at our train management system, CCF, to see where the train has been. So that was quite a long and laborious task. And as you can see, as we all know, inside Paddington Throat is a very busy area. So it's other parts of the network. So bridges have been a place to run to when it all went wrong. So during CP6, late CP5, CP6. So late CP5 wrote the requirements document in CP6. These pantograph monitoring stations were installed across the network. And as you can see, we've got a couple of London, Reading, Didcot and Bristol. And we've got Heathrow installation as well. So we've got the route pretty well covered, and they're strategically placed. You can see we can run trains in and out of Wales. So we can see if we've got a problem in Wales. And in the Severn Tunnel, we've got Didcot, which is the halfway point, give or take. Trains going down to Newbury from Southcote Junction, and then trains in and out of Paddington Road and covering off some of the cross-rail services. So vegetation, because we've got bi-mode trains, and trains go down to the West Country and into West Wales, they can come back with vegetation. So we use PanView to help us pick up vegetation issues as well. Okay. So just an overview. We touched on the system, sort of briefly how it works, and where the line side monitoring is. Yeah, and you can fit them pretty well anywhere. And it's rather than having an independent portal to put them on, it's wise to put them on an existing structure. So as you can see there, we've got Didcot on the right, Paddington approach in the middle, and then a Heathrow on the left. So they're pretty universal as to where you can put them. As long as you can get a view over the top of the train, you can take a view. And then this is Jay will go into this in a bit more detail later on the case study. But this is the dashboard you can see with Camlin, which is the system we use, and PanView. So you can see that we've got the RAPs, what we call the remote acquisition point there. You've got the alert level, the horizontal bar there for the events, and then you've got where they are in those columns, and speed of the train, pantograph type, and the time of the incident. So, for instance, the top row there is grey. That's where the data is being processed. Red, that there's a fault. The greens, like black, where you couldn't pick up an event. So that's what the dashboard looks like, and there's a series of other tabs you can look at to give you more detail. Again, so we'll come on to that in a few moments. Again, this is another view. So, got the pantograph camera view looking down. Got the model which it produces. These two black marks there. That's actually the shadow of where the contact wire is. Obviously, the cameras can't see there. You can measure carbon thickness, as well as the twist and the yaw of the pantograph head. You can measure orientational movements and so on. So quite a lot you can measure just by taking those photographs and putting them into a model. And it will also tell you the depth of the damage and where it is on the pantograph. See that in a second. Okay, so pantograph monitoring, as we said earlier on, isn't new. Pan checks were developed in the 90s. These standards were sort of produced after pan checks, I guess, but these are 2006 and haven't changed. These are Network Rail internal standards. They haven't really changed, and during the sort of start of the project and doing product acceptance, there was a bit of a tussle between what these standards said and what the equipment could actually do. But nevertheless, product approval was obtained. So maintenance support and of the equipment. There's a service level agreement with Cambium for PanView, and we have four weekly meetings then to discuss the performance of the system. And then there's a 2-yearly high-level inspection to go up and service the kit. That may change it to be pushed further out in the future, but as it stands, it's 2-yearly. And then we do some low-level lens cleaning. So the lens maintenance is important, just like how many glasses on. If your glasses are dirty, you need to clean the lens. So we do an annual clean off a pole. There was an isolation in place. They're insulated poles, as you can see, but that was done under an isolation just to give the lens a clean. Otherwise, you end up with a bit of fog, which is what we see on this slide. So to the untrained eye, those pictures don't look too different. But to the eye of PanView, the difference between what it's looking through is quite different. So and the difference between usable data and non-usable data. So there is that was one of the hurdles. We didn't steam engines clutter up lenses and diesel engines and so on. So something we didn't foresee to be able to really clean them from the ground, the lens from the ground, but nevertheless, now they get cleaned from the ground annually, and then we do them at high level. It is solved. Okay, over to Jay. Thanks very much.
Oh. Yes, good afternoon, everyone. So next I'll be talking about some case studies from PanView, as well as thermal imaging trial we've done as well. So these case studies will essentially go through sort of process we applied when we had like an incident happen related to Pantograph, and how we use PanView to essentially find a solution and then rectify that as a result. So case study 1, I'd just like to introduce the concept of contact wire uplift. So traditionally, this is measured between the static position of the contact wire with no pantograph present. So that's 0.0 millimeters of uplift. And then when a pantograph passes at a point, you can take a photo, and you can then calculate the difference in contact wire height as the pantograph imparts the vertical force on the contact wire. Now, the way PanView does that is slightly different, given that it is taking a picture already under a dynamic condition, so your reference point is already different. So the way it does it is that during the commissioning of a system for a sort of 2 to 4 week period, it will take an average of where the contact wire is across those 4 weeks, that is then your baseline or 0 mm reference point. And from then on, any event with a pantograph and wire above that reference point, that's then known as positive uplift. Anything below that is negative uplift as well. So in terms of how you sort of analyze the uplift, this is the way you do it. This is the way we do it. So there's an analytics page as part of the Thea dashboard that Darrel showed. And this is the normal distribution you would expect. So this is just a normal bell curve of distribution centered around the x-axis, -10 to +10 millimeters of uplift offset. So you'd expect everything to be around 0, indicating that everything is within that reference point, which has been set already. And then you would expect the uplift offsets to then drop off in a nice sort of curve shape as you increase in positive and negative uplift. So in terms of an incident where we had to use this feature, we had an ADD on the 8th of December 2023. So an ADD is an auto drop device in the pantograph carbon, so a pressurized tube. Essentially, if the pantograph carbon takes sufficient damage, that tube will depressurize, drop the pantograph to protect the train and the pantograph as a result. So we were presented with the image in the bottom right indicating pretty serious damage had occurred, and sort of the normal process we apply is to then request pantograph camera footage, which you can see in the top right there, which was taken inside Heathrow Tunnel. And the problem with Heathrow Tunnel is that it's very dark, it's not lit like most tunnels, and the best information we had to go off was that image, which just showed some arcing and some steelwork between the pantograph and that. Then we went into the PanView system itself, looked at the previous event for the train for ADDs, and we saw that image on screen indicating that there was already damage present, and pretty serious damage at that. On that leading carbon, you can see 2 big chips already on there indicating that something had already gone wrong, and that essentially that ADD wasn't just isolated to that one journey that train had made. So question to keep in your head, and a question we had to ask ourselves was, what is different about the OLE in Heathrow Tunnel? Why did this train ADD only there? Why didn't it happen anywhere else? So going on to, again, the analytics. So for this relevant train, there is 2 pantographs present, so therefore we have 2 different sets of uplift to look at. And this particular site had an issue with the uplift offset, essentially where the graph was shifted to the left. So there was an incorrect offset applied, but the shape and the curve distribution is still as you would expect. You can just think of the graph I showed you before as moved along to the left. So the information is still useful. The numbers not quite so much in terms of the exact numbers, but it did show us was that for one of the pantographs, the one on the right-hand side, that distribution is as you'd expect. Things were centered around one particular uplift value, and then with very few events beyond that as well. But for the other pantograph, the one on the left-hand side, you can see on the left-hand side there, you had 12 and 11 events with a difference in uplift 50 mil. And that is the useful information to take in, that there was 50 millimeter offset in some events for whatever reason. Now, just what does that actually look like? It doesn't look like much. So you can see here, that's what 50 millimeters of uplift difference looks like. And normally for conventional sort of overhead line systems outside, that's not a problem. The system can tolerate those differences. You wouldn't get a problem generally. But in Heathrow, things are different, as I said, and this is how things are different. So clearances between the overhead line and relevant steelwork in some areas is very, very tight, especially in areas where you have new wires coming in and other wires going out. You can just imagine on the left-hand side there how 50 millimeters of uplift difference between that contact wire and that piece of steelwork could cause the pantograph to hit that with some force. So we had the maintenance teams patrol the area as normal, looking in the first instance for if there was anything on the overhead line hanging foul, any evidence marks of anything. They did that twice. They didn't find anything, and the other information we had already was In that time, no other trains had showed any signs of new chipping, or no other ADDs had occurred. So that was indicating to us that this was currently isolated to one train, and in particular one pantograph. So after many discussions with the relevant TOC, we agreed that it would be the best idea to just do a complete pantograph assembly change, essentially reset the system and see how it went. And after doing that, and with the relevant offset removed from the distribution graph for that area, this is the new curve that we've had as of a few weeks ago, across perhaps like a month period, and see that things are much better, sort of centered back to where we'd expect, and things are performing as they should. And I'm still checking it every few days. There's been no new signs of damage or anything like that. So that's just one example of how Panview has managed to isolate an event very quickly to exactly what's going on, and before a more serious event could have caused inside Heathrow. Something to also note on this in terms of uplift, as we move to sort of a world where VCCs are more prevalent, clearances get much tighter. It's good, that's good. And the VCCs will protect structures, the overhead line and the trains, but it's also important to understand how uplift comes into play where you have VCCs now, because if you have a train running around road uplift, you can quite easily cause much more serious damage than you would ever normally get. So it's important to understand and probably introduce uplift monitoring systems. Maybe not this, maybe an onboard train thing, but uplift should be considered, as generally it's not really measured in service, apart from a few monitoring systems like this. So moving on to the second case study. So today, this is Darrel suddenly started receiving a lot of chipping alerts on the right-hand side. You could just see the frequency they were coming in at, and this was a complete step change overnight. And this was isolated to one area, so we were only getting these in and out of Heathrow, and these were only limited to one particular train type. So that's already some information to go off, and that's what we used to start thinking about whether this was just location dependent or not. So what did that look like? So on screen is three examples of the chipping we were seeing. So towards the center of both carbons, we were seeing big chips again, similar to the one before, but slightly different, as this was on both. So that this was also, we knew already this was a bit different to what we'd previously seen. And in terms of what Panview could do, it can do an estimate of the size of the chip based on the width and area that it sees through all sort of image processing techniques. And you can see that it's quite a big shape. But as I said, we were seeing this only on one specific unit type, so we're starting to think about what this could be. And again, going back to sort of analytics, where this power of harvesting all of this data comes into its own, really, is this graph here. So this is a chipping distribution graph. So on the y-axis there, towards the center, you've got the carbon center point. So that is dead set in the middle of both carbons, and then on the left and right of that is positive and negative measured, and you expect the normal working area of the pantograph carbon to be minus 230 to positive 230. Looking at the x-axis, you can see, as I said, that it was a step change overnight. January the 19th, suddenly had a massive influx of chips, all around sort of 100 mil from the center point of the carbon. So after sort of discussions and based on sort of relevant experience as well, it was assumed to be that this was likely to be caused by a section insulator in some way. So this is a Arthur Fleury HI25 section insulator. So what this does is just separate particle electrical sections of the overhead line system, and you most commonly find these around crossovers and sensor points and such. So we had the team, again, as I mentioned, like we did in Heathrow, they controlled the track, had a look around at all the SIs, and luckily did find the culprit. So on screen is an image of the suspect section insulator. So you can see in the box in red that there is an upwards groove and gap created between the insulated rod and the metal fitting. And you can sort of understand how a pantograph going over that, imparting significant force in the upwards direction, would catch on that gap created cause those chippings to appear. And what you can also see is just that rod should be white, brand new is white. You can see just how dirty it is through arcing as it goes through. And the believed cause of this is to be, over time, the cant between the SI and the track has gone out of alignment. So essentially that the train is riding over at one angle, the pantograph is as well, but the SI is at a slightly different angle. And then the pantograph is going over one of the rods harder than the other, and you get excessive wear on one of those ends. So just a couple final things on plan view. ICE is quite a new thing. We've realised that it can help monitor. So I had discussions with the manufacturer just sort of at the back end of last year after I found that at Didcot there was some good images coming through of arcing on the carbon between ICE and the contact wire. And it's important for us to be able to manage this and have this as an additional feature is good, because in the worst case you get the image on the right hand side from 2023 whereby you get excessive localized wear and also heating on the carbon, but also the aluminium carrier as well. You can see that it's blown a hole between the two. So this is important for us as the infrastructure managers, for the TOCs, and also for the carbon manufacturers themselves to understand if anything can be done to sort of mitigate against this. So this one is more of a new work in progress for Camden, but good nonetheless. Lastly, and arguably, to be honest, the most important is the ability for PanView to alert for pantographs which are completely out of alignment. And the reason for this is these are the biggest risks of immediate dewirement. And these three on screen were alerted to us and immediately taken out of service on the overhead line. And you can see just you get all sorts of different alignment issues through different causes. And you know, if left untreated, these can easily snag on the wire, drop up or any associated wire, and then bring the whole thing down. So you can see the obvious, but also the not so obvious. So in the bottom right, I've tried to zoom in to show what that issue is. So that spring-loaded fitting should have a bolt going through its center point. And over time, it's likely that image in the bottom right would end up looking like the one in the bottom left, if left untreated. So next, I'm going to talk about thermal imaging of the overhead line. So this is a trial we've worked on in the past year for a specific problem we had as well. So historically, it's been done through the Network Rail AirOps helicopter, which is fitted with a normal camera and also a thermal camera as well, and has been used on days just to do a survey of a particular area, and is able to find discrete issues on that day, such as the one on screen from 2017, which was a switch not closed properly, causing arcing between the blade and the contact. So this was dealt with on the day. The problem is that will only show you an issue on the day. What it can't do is help you for things like this. So we had a flurry of earth wire failures suddenly appearing with no immediate and obvious cause. And earth wires generally do not fail unless something falls on them. It takes something a bit particular for them to fail in the way they did. Looking a bit more in detail, the problem we were seeing was there was excessive current going through the earth wire and in particular clamp, which should not be the case. They should never ever look like this. And it's important to bear in mind that the melting point of aluminium is about 600 degrees. So these components. So something was seriously going wrong with the traction power system, with distribution, traction return, all sorts of things going wrong there. And the reason we were starting to think that the clamps were causing clamps with a failure point is that the clamps are generally only rated for fault current conditions, not for continuous current carrying conditions, as the earth wires are themselves. So as I said, how do you monitor a moving fault? Helicopter isn't really suited for this particular application, nor is it financially feasible to run a helicopter 5 days a week for 10 hours a day. It just doesn't make any sense to do that. So we had to think, how can we approach this slightly differently? So what we did was we worked with a company called One Big Circle, who developed the AVA platform, for those familiar. And the box on the screen is their third rail thermal monitoring camera. What we did was we approached them and said, do you have anything that can do thermal imaging? They said yes. Then we asked the question, can you modify it for the overhead line? They said yes. So what they did was oriented the thermal camera, which is at the top of that box, and the non-thermal camera in such a way that it would essentially look at the overhead line and take good video footage of that. So what does that look like in practice? So this is the AVA dashboard, as I mentioned. So you're able to flick between non-thermal and thermal view. And in the sort of bottom right, you can see that the software will then flag up any thermal hotspot detections, which you can set the temperature to whatever you like for it to detect. So in this instance, this was a trial. This was using the existing algorithm from the third rail system. So it was just to see if it would work essentially, and more so just to get the footage rather than the detections weren't the key part of this. The key part of this was just to get the video footage of the system. This is just a screenshot of an example location of the non-thermal view. And this is the thermal view. So quite a different view, as you'd expect, and a good view nonetheless. You're able to quite easily distinguish different features of the overhead line system, as well as the track as well. What we did, we ran this for weeks, months, and still using it now. It's sort of become business as usual. And it was able to find areas that had not failed. So that the whole point of this was to find things before they failed, intervention before failure. And it was detecting some earth wires, in particular the clamps that were showing hot. So we've got the example there of one at 43 degrees, got another one there at 128 degrees. So that one especially is well on its way probably to failure. So catching these early was key, and that was the whole reason for this trial. But as I said, it was a trial, so it wasn't detecting everything. We didn't expect that. There was still a bit of manual checking to do. Luckily, we were only running this in a relatively small area, so reviewing footage manually didn't take too much time out of anyone's day. So following that, we found there's actually quite a few use cases for this, we think, rather than just for our specific problem. We think it could be used for entry into service testing to see primarily if you have any install issues related to things like switches or any bonds in the traction system. It also shows you thermal performance of the overhead line system in tunnels, which has not really been done before, especially on our region. This was the first time we had a good look at the tunnels, how they're performing thermally. So you've got an example there of Heathrow. You can also see the thermal performance of the overhead line in different load conditions. So you could run it in the morning peak or the evening peak. And likewise, you can do it. There's not much load at all to understand how things are performing differently. For us, the biggest one was we can actively manage known thermal risks, so we can see if things are getting worse or not and the rate that they might be degrading to help us understand whether we need to intervene and when. And lastly is for extreme weather monitoring. So we do plan on running this, for instance, if we get a heat wave, we can deploy this and run this in a particular area to understand what temperatures we're seeing on the system. And not also just for the thermal side, we also have the non-thermal view as well, so you can look at the other assets as well. So it's not just the thermal, the camera is 2-in-1, so there is a benefit for other things as well. I'll just hand over to Darrel to close off.
Thank you. Thanks very much. We're almost there. Thanks for your patience and thanks for listening. So yes, so PanView, as where we started, it's been not quite a national uptake on PanView. Pantograph monitoring, PanView has been used on a couple of other network rail locations now, in Manchester Metro as well. And as you can see, is widely used in other countries now, and sort of North America and Far East. But with the initial install on Heathrow and then coming down the Great Western Main Line. So we were sort of pioneers in some of that development, really. So it's important, asset health is important. So if we look at Pantograph and contact wire, PanView gives us that view. As we've seen, certainly saved some deployments on the Great Western region in the last couple of years. Ties in with the aspiration of GBR, bringing track and train together. and everything in between, which is good. So I think it's an important tool for us, and this has given us good benefit so far. So,
Sorry, I had a question should be after, but I've got to ask you while you've got that slide on.
yeah.
Why are the other regions not using it? Is it because they use something different, or they just don't have a system?
I know Northwest and Central are exploring it. I can't say they're exploring
But
it.
they're not
Scotland are
using
using the Ricardo rail pan system.
Yes.
They're using-
okay.
Because they got it. Yeah.
I know Northwest and Central are looking at one, and its pan view is in at Hendon. I think, yeah, so that's in at Hendon and a couple of other locations. Anglia are looking at it because whilst we can look at trains going in, because we can't, there is no monitoring on the other side of the tunnel, so not logic to put something there. So yeah, so lots of acknowledgements. It's been a bit of a project. It's been slow because of access and resources and so on and so forth. But nevertheless, we got there. And a big thank you to all the ones involved on the screen there. So there's been numerous. I won't go through them all, but you can see where they are. And a big thank you from Network Rail. Thank you very much. So then we move on to any questions. We'll try and answer.
I can see Gary's been answering online queries
Couple of
throughout.
them, yeah.
Was there anything in there, Gary, that you want to
Yeah, just
pick up?
bring them up a minute. Hang on, sorry. So,
Well, you look, Eric.
yeah.
I've got a question. So, did you have to put in any deviations against Network Rail standard for pantograph monitoring sighting?
No, sighting wasn't an issue.
For this, if you've said that you've decided that it was the existing standard was for pan checks rather than your.
It was related to pan checks, but it was
Yeah.
for pantograph monitoring systems. But the sighting one wasn't an issue. There was one about weather temperature.
The standard is essentially a description of pan checks.
Yes,
That's
no,
it's a
I-
standard
that-
written around one technology. So,
Yeah.
Yeah, absolutely. And sorry, that's where I was getting at.
It's up to date, quite right.
Yes.
Um,
Because then there's sort of you've got to make sure it's on a straight track and all
Yes.
this kind of stuff, which with the image monitoring and image recognition you don't necessarily need to do. And the reason for did you have to put the deviation into the standard that was not applicable? Because if it was
for a deviation in which it wasn't applicable. And I think there was an aspiration to rewrite those standards.
Yeah.
So we did Atkins Realis did the outline design in the first site, which is Southcote. So we kind of developed the selection criteria for the locations. It is quite complicated actually. There's a whole bunch of things that have to be true. You need a power supply. You need plain OLE, no SSC, no overlaps, nothing else like that. You need a big fat structure that's got plenty of spare capacity. This is why we decided the mono foods would suit well. So yeah, it was quite a complex process to select. But it was we completely ignored the standard, to be honest. It just wasn't appropriate anymore.
And that was a little bit tricky with project approval because they would say, well, this is the standard. And it didn't align, but we got through it. Yeah. Anything else?
Yeah.
Any other questions?
Big question online.
Yeah.
So Mike Lipscomb asked, can it check for excessive pantograph uplift? I think you answered that one pretty categorically. I'll add a follow-on question for that. Is it fair to say that although it's very useful to see, as you say, differences, the absolute magnitude of the uplift is probably going to be low accuracy generally?
Within a tolerance, yeah.
Yeah.
But it's all the important thing is to make it all relative to what you're seeing as the norm within the system itself, rather than looking at an event in isolation.
Mike also asked how is the system powered. I answered that one. It's still 230 volt single phase. Yeah, it's fairly. I can't remember how many amps it was, but it was pretty low current, isn't it? So it's quite easy to tap off of the existing supply. Yeah. Take a question.
Yeah, any questions in the room? I knew you would, Paul.
Just recalling when you were talking, Paul Barnes, he did some research, I think, with Oxford University, I think, about the position of the contact wire, measuring it as it moves along the pantograph.
That was a different system.
Yeah. Was
You're
that,
thinking
was that,
about a system on the train looking at the OLE.
yeah, was that
You
developed
need,
further?
you need both, don't you? Because you've got this system's
Yeah.
on the infrastructure looking at the pantographs. The only way to monitor the OLE is from the train,
Yes.
realistically, isn't it? So you need both sides to understand what's going on at the interface.
So that system called alert, and we have that on 4387 GWI 387. Yeah.
Sorry. Your temperature monitoring, and you're looking going to run it down track on hot days. It'd be interesting to see how well validated the system design for temperature, conductor temperature, is then done for that. Because I think there was certainly in the allowance from the system design there was a ambient temperature from the wires. There was a current heating allowance and stuff. I appreciate you're not going to be able to split down if it's come from ambient temperature or current, but it'd be interesting to know if that original specification for the conductor temperature was anywhere near how it is. So
We can probably look at a loop line on the same day.
oh yeah,
You really want to do that when you replace the equipment in 7-ton. Replace it if you're going to go with that single contact wire.
Yes, yeah, well, we do.
And just to add on to that, I didn't show it in there, but because you're running it on a live train, there is plenty of footage available of when a train's coming on the opposite line.
Yeah.
You can just see that there is a slight warming
okay,
at the interface, very slight.
Yeah.
Not too much difference in the actual temperature, but it is able to pick up those
Yeah.
subtleties that I mentioned.
yeah. So that'll give you some idea about your system resilience and climate resilience going further forward, wouldn't it? So
Definitely.
yeah, thank you.
I've got one. I remember in the early days there was some uncertainty about how the system was going to actually know which train the defect was on, how it was going to actually identify the train. I think they were talking about RFID at one point. What was the outcome of that?
MVID, so it's a vision system, and it reads inside the coach. You can read the number.
It reads the number.
Reads the number.
Matches to.
So to be fair, we did sort of mask out the
Yeah.
unit numbers.
And does it automatically match that to the head code of the train then?
No,
Not head code,
No,
just unit number.
that
He's
is
then got to go to the train operator and say, "Where's this train? What diagram is this on?"
that is easy.
That stuff, right?
Yeah.
And that makes it very easy then, yeah. So it's not too difficult.
Yeah, but on the event, you'll get coach number and also the unit train number as well. All in one. You know at least exactly what train.
Yes.
Do the train operators have access to all this as well?
No, not at the moment, but they will do. So what we do, we share the events with them.
Yeah.
For the minute. And there's been some interest because you can look at it, in a different way. We've learned quite a lot of things going on. And I think if you look at those pantographs, which are looking a bit ropey. Now in the past, we've not been too sure about, was it the pantograph or was it the OLE? Whereas this gives you a state of what's running around. So yeah, it's good. Yeah.
Couple more
Yeah.
online.
Oh, sorry. But my question is initially based on the gentleman's question on about the relevant talks of train manufacturers' access to the pay-per-view information. But can I know if that's in development, or would you intend in the future to share this piece information with talks with the train manufacturers? And will they have a chance to get some early warnings?
Yes. So we're in the process of arranging access for the talks. They will have, because it's a very useful tool, but real benefit comes from the talks using it as well. If we just look at it and it's in very much in isolation, if it's opened up to the talks, then that's where the true benefit is. And even things like with the MVID system, machine vision identification, they can use it for graffiti. So they've got, and that gives them a bad reputation. But rather than having to say, well, which train's got graffiti on, I mean, you just do a sweep. So MTR were very interested in that capability, and vandalism and all that. Well, it is vandalism, isn't it? Oh yes, thank you.
So can I just confirm at this point, at this moment of time, this information are only being shared with the talks case by case?
Yes, it is. But as Jay mentioned there, that when we had that incident with the uplift, there was a lot of dialogue back and forth and to get to the bottom of that. And that took some time. That wasn't and they were a little bit reluctant to change the whole pantograph head. But all other options were exhausted, and they did, and that's not the problem. So there's nothing wrong with that pantograph assembly.
A question on the front.
I'm just my curiosity, because I can see the camera taking some black and white photos. You're using some particular software and software to analyze the pantograph, but is it targeting particular type of pantograph, or it can be used on any type of the pantograph we use on the route?
Yes, they will pick out different types of pantographs, so they're sort of set up. So if we run 2 types, HSP Mark II and HSX, but if we were to run, say, Mark I pantograph, then we would notify system provider, and then they would train their model to look for that system.
It can be trained on any
Yeah, can be trained on any pantograph, and indeed in Europe and other countries they have different pantographs, so it's just a matter of adapting there.
Yeah, it takes a picture of anything within that trigger range. We've had pictures of birds, basically. So,
The other thing we didn't mention was, and it's really been helpful, is that when we have an overhead line trip short circuit and we don't know the cause, the first thing we do now is look at pattern view to see have we caught a pigeon or a piece of vegetation. Now, it's probably, I don't know, one or 2 times out of 10 there's something in the pantograph, not every time, but it is something we will go to and say, oh yeah, well that's the reason for that tripping. And vegetation is one. Vegetation, we've had a number of cases down in Cardiff and at Newbury where we've brought in vegetation from the West Country or West Wales, and then we've decided to pan up and add a trip. But when we get past one of the units to say, oh yeah, you've got some vegetation, so it is good.
Is the system used by the sort of local maintenance team, so they can access it, look at the
Not at
information?
the minute. This is just
they are soon to be trained on it.
Right.
we've got a repair to do at Didcot, which is scheduled in the next few weeks with the illuminators. The heaters went off the illuminators for the winter, and long story, but the illuminators will be changed, and then when all the systems are back into working order, they're brought up to maintenance.
With the average cost of a dewirement, and you've said you've saved 3, presumably that's vastly paid for in production of the system itself. So will you therefore be looking at Newbury and other sites like that to put in vegetation monitoring cameras or similar?
That has been mentioned.
Yeah.
Yeah, Cardiff and those. That is
Newbury,
Fun-
Chippenham.
funds permitting. That would be one to look at.
Well, you've got your justification there, haven't you?
Well, it's good evidence. Yeah, it is. It is good evidence to support that. Got a couple more questions.
Yeah. We've got, I'm probably going to get this person's name wrong. I apologise in advance. Voirol asks, trained IA software would analyse the images much quicker than people. Is there room for further development?
It is analysed through AI.
So,
The images I've shown were just the examples of the images it had seen, but and the reason I knew which ones to look at came through as an alert.
for the machine.
Yeah, absolutely.
Chris G says, regarding the one big circle thermal camera, how effective was it when it was turned upside down to review the OLE, given that it was designed to point at the rail normally?
We never used it in that. The first time we put it on was after they moved everything around.
Yeah.
So we never saw that view. So our first use was it looking up.
And they're not easy to modify it or modify the software in any way.
Darrel went to the original trial at Reading Train Depot, a little bit of tweaking the movement.
Take the front of the box off and give it a poke and to see, somebody's watching it on the laptop to see if it's looking in the right place. Yeah.
We haven't had to do anything with it since really.
And the last one is Robert W says, is there any link made back to pantograph maintenance when identifying a particular unit? When we used the iCheck system back in the 2000s, we caught a few units whose performance started after overhauls or replacement.
Absolutely, yeah. So that particular uplift issue, as Darrel said, we went back and forth with the relevant TOC and train maintainer as well, and they did their own depot measurements and tweaks, and it just wasn't working. Nothing was working that they were doing through no fault of their own. I think it was just a very discrete problem and an intermittent fault. Hence why then we let it run out again, but we're still seeing uplift issues. So then the decision was taken to just change the whole thing, and it turns out it was the right call.
From our experience doing dewirement analysis a few years ago, Bretton Willis pantographs are very sensitive to set up during overhaul maintenance, particularly the lifting chains. You know, the torque on the lifting chain bolts has to be just right. So our suspicion is that there's quite a lot of variation in
That piece of work,
static force.
that piece of work is still ongoing with Harry at Watt University as we speak. There's still some work to be done there, or is being done. Jay's done some work with TFL on the central operating section with the overlaps. So we had a bit of chipping on the back of that, 3, 4, 5. So Jay's provided some data to TFL, which has been useful. Yeah. Okay.
Great.
Thank you very much.
Any more in the room? I think we're done. Thanks, both. The big clap and publish.